I'm Regina. I'm the global head of KPMG's energy practice, and KPMG has been pleased to have collaborated with the center for the last several years. I remember the last time we did this last year, we were face to face, so we're all getting comfortable in this virtual environment. I'm excited to be moderating this interesting discussion on the pace of change required to achieve our global climate goals. Today we have two internationally known thought leaders on energy and climate issues. We have Jules Kortenhorst, CEO of Rocky Mountain Institute. Jules is a recognized leader on global energy issues and climate change, and his background spans business, government, entrepreneurship, and nonprofit leadership. We also have Amy Myers-Jaffe. Amy is the managing director of the Climate Policy Lab at Tufts University's Fletcher School. She's an expert on global energy policy, energy and sustainability, and geopolitical risk. Prior to joining Tufts, Amy had held a number of high-level academic positions, including serving as the founding director of the Baker Institute's Energy Forum at Rice University. So it's great to welcome Amy virtually back to Houston and have Jules as our second keynote by a leader from the Rocky Mountain Institute. I'm going to ask Jules to speak first, and then I'll ask him a few questions on his presentation, and then I'll invite Amy to do the same, and we'll have then the three of us together answering some questions. So if you have any questions for either speaker, please type your questions in the Q&A box. Okay, Jules, the floor is yours.
Great, thank you very much, Regina. Delighted to talk to you. I hear a horrible echo, but that may have disappeared now. Good. Yes, good afternoon, everyone, and honored to be speaking to you about the pace of the energy transition. In our view, we are facing a planetary emergency as a result of climate change, and therefore we need to accelerate the pace of the energy transition. Because it's important to realize that with climate change, accumulating more CO2 in the atmosphere means that climate change becomes more and more inevitable, and winning slowly is therefore the same as losing. We have to move fast, we have to reduce greenhouse gas emissions by 50% over the next 10 years and achieve a net zero energy economy by the middle of the century. We'll go to the next slide. And that is a daunting challenge, to think about a net zero energy economy by the middle of the century is a massive, massive shift in the way that we use energy around the world. At RMI, we believe that there are four key pillars to making energy a part of this transition. The first one is to dramatically improve the pace of energy productivity. And we feel very comfortable that this can be done, that this can be achieved, but it requires us to focus our attention and our capital on driving the productivity of energy, just like we drive productivity of many other parts of our economy. The second pillar is to make sure that our electricity system becomes 100% clean, that all of the electrons that we use in our electricity system are those that are produced without emitting CO2. And that clean electricity then also becomes the critical enabler for electrification of parts of our economy that currently still run on oil or gas. In particular, our cars and our buildings. Mobility and the built environment can relatively easily be electrified with clean electrons and thereby reduce greenhouse gas emissions by another 50%. And then we have to fix the rest. There are still some segments of the economy that are harder to electrify and where we can't get there with energy efficiency alone. For example, petrochemicals, steel, cement, aviation. And we have to develop and implement the technology solutions at scale that drive emissions down in those sectors. Next slide. The good news is we believe that this transition, that this shift is happening at a much faster pace. There are really two competing views on the speed of the energy transition out there. One perspective, which historically has been the perspective of organizations like the International Energy Agency and BP. That was also core to the philosophy that Shell held from Kramer and Hague. That view is that transitions in the energy system take a very long time. They happen slowly because we're talking about a massive shift in an incredibly capital-intensive infrastructure. But maybe the world is starting to look different. Our view at Rocky Mountain Institute, but also the views from IASA and Greenpeace and other organizations, is that the energy transition can happen much faster because we are talking about a very different character of transition now than in past energy transitions. And there are 6 drivers to highlight when it comes to this pace of the energy transition. The accelerating pace of technological change that leads to dramatically declining costs, momentum behind the policy direction around the world, the fact that this energy transition is not just something happening in the developed world, in Europe and the United States, but is also happening in emerging markets, and those countries are leapfrogging straight away to the technologies of the future. The fact that there are integration loops in our energy system that are mutually reinforcing and that are helping to move the transition faster. So for example, as batteries become cheaper because of the scale up of electric vehicles, they also become available for our power system. And finally, the role of financial markets that are starting to buy into the view of an accelerated energy transition and therefore shifting capital from high carbon to low carbon. Let's look at 2 specifically. First, the declining cost. Innovation is driving an unrelenting reduction in the cost of solar and wind and batteries and other clean energy technologies. These cost reductions are also referred to as learning rates. They basically mean that every time the globally installed capacity of these technology doubles, the cost of those technologies comes down with a consistent percentage. For example, every time globally installed solar capacity doubles, Bloomberg New Energy Finance has calculated that the cost comes down with something like 28%. And that is incredibly fast. That means that we've seen year on year on year cost reductions in solar, in wind, in battery storage that has been impossible for other energy technologies to keep up with. On top of that cost reduction, we are now starting to see a more and more supportive policy environment. Next slide. That policy environment, oh, we moved 1 slide too far. That policy environment is driven by a global consensus that has emerged on the climate science. You might not fully realize that when you look at it from a US perspective, but around the world, governments, businesses, investors, mayors, states, provinces, universities, all have come to grips with the fact that the science on climate change is crystal clear, that we have to limit global warming to 1.5 degrees because otherwise the climate impacts are unbearable. And that we have to particularly prevent a switch from one equilibrium that has sort of enabled the development of human civilization over the last 10,000, 20,000 years to a more dramatically different hothouse Earth that potentially makes life on this planet very difficult. And that opinion has shifted. Partly we see that in public movements like Extinction Rebellion, Greta Thunberg, the young student that has been leading the school strikes, Sunrise Movement. We also see that opinion shifting in the legal arena, where legal pressure is mounting with lawsuits against oil and gas companies here in the United States, and a verdict, first of its kind in the Netherlands, where an organization called Urgenda forced the government to adopt a much more ambitious climate policy on the back of a ruling of the Supreme Court. And civil society action and financial pressure that are also mounting. And businesses around the world have taken note of these shifting opinions. Businesses around the world have started to commit to increase their procurement of renewable electricity, to make science-based targets that align their businesses and even their financial portfolios with the science of climate change and the goal of 1.5 degrees. And as a result of that, we are starting to see pressure on companies, not just from consumers, but also from their shareholders and their investors, as well as from policy. And policy is accelerating around the world. Around the world, governments are recognizing that there is actually a world out there beyond the decarbonization of our energy system that is promising. Next slide. So this is happening in the electricity sector, it's happening in mobility, it's happening in our built environment. But I want to focus for the rest of my brief comments here about what is often referred to as the harder to abate sectors. Those parts of our economy where the answers are not yet always immediately clear. Because people have talked in the past about the fact that these sectors would really be the stumbling block to decarbonization. And our view is that that has historically possibly been true, but right now we're seeing a rapid increase in the technological solutions for these harder to abate sectors. In trucking, we are seeing electricity emerging as a viable answer, certainly for short haul, local distribution, but increasingly potentially also for long haul, heavy duty trucks. Digital innovation is accelerating, allowing us to increase the renewable electricity that is intermittent on our grid, even to the point where we can have a fully clean electricity grid, which we didn't think historically was possible. Aviation and shipping have been hard to contemplate. How are we going to create ships that can sail without marine fuel? How can we fly planes without jet aviation fuel? Well, new solutions are emerging at a very rapid pace. Electric airplanes are being tested. Norway has already determined that all domestic flights have to be electric by 2040. Electric ferries are out on the waters. People are talking about hydrogen or methanol or green ammonia as the fuel for ships. So new solutions that we didn't think were viable even 5 years ago are rapidly becoming possible. And a very important part of all of this is to convert our cheap renewable electricity into green molecules, most likely green hydrogen, as the core energy carrier for many of these hard to abate sectors. And finally, I'll just mention that even in a sector where some of the emissions are inherent to the process, like cement, we are starting to see the emergence of new technologies that allow you to cure cement with CO2 rather than with water, thereby dramatically reducing emissions. Next slide. So, two examples in particular. Delivery trucks, certainly for regional short haul, for delivery around the city, but even for long haul, are moving to the zero emissions designs that we couldn't imagine 5 years ago. It's not just the launch of the Elon Musk semi-truck about a year ago, and that truck is due out in the next year, and significant orders have been placed for that truck. It is also companies like Rivian that does delivery trucks. Amazon has placed over 100,000 orders for those delivery trucks in order for it to live up to its commitment for climate neutrality by 2040. And hydrogen-based electric hybrid trucks like the one that Nikola has announced. So it is our expectation that trucking, where for the longest time we thought that it would be really difficult to decarbonize, will move to a decarbonized reality over the next 10, 15, 20 years. Next slide. And then the hydrogen sector. And the hydrogen sector is particularly important if you think about a city like Houston, where so much of the historical industry has been based around molecules rather than electrons. Hydrogen is going to become a critical clean molecule that allows us to translate the green electrons from renewable electricity into the fuels for shipping and for aviation and potentially for long-haul trucking, but also for industrial processes like steel making and petrochemicals. And at the moment, hydrogen is still more expensive if it's made from renewables and electrolyzers. But that is poised to change now that regions around the world are announcing very large scale-up projects for hydrogen. In particular, the European Union, as part of its Green Deal, announced over the last couple of months significant gigawatt scale deployment of electrolyzers around the European Union to drive down the cost of green hydrogen to be competitive with hydrogen from steam methane reforming. So there's a lot of exciting things happening in the area of the energy transition. The pace is accelerating, and it is up to cities like Houston, states like Texas, but also countries like the United States to decide whether they want to be part of this transition and want to lead from the front. Thank you very much.
Thanks, Jules. That was great. Shameless plug for Brett and the Center for Houston's Future, because they have actually done a study about what Houston can do as an integral member of the hydrogen economy, leveraging the infrastructure that we have today. So, you know, I think your points are landing on sympathetic ears. A couple questions, though. I think I heard you say, to correct me if I'm wrong, that your premise is we need to be a net zero energy economy by the middle of the century.
Yeah.
So what do we need to do in the next 10 years to get there? I mean, that's an incredibly aggressive goal. So what do we need to do this decade to really drive to achieve that goal?
Yeah, that's a very good question, Regina. And I'd point out that the real challenge in making this transition is that we are replacing an installed infrastructure, an asset base, and that simply takes time, right? So in order to hit net zero by the middle of the century, that means there are no incremental emissions of greenhouse gases from the energy system. By the middle of the century, we need to really start replacing our assets already in the next 10 years and drive down emissions over the next 10 years. Calculations of the International Panel for Climate Change, the UN body that assesses science, tells us that we have to reduce emissions already by 50% over the next 10 years. And the first step we have to then take is to make that electricity system green. If we make our power sector green, then we have clean electrons that we can use to power our cars, to heat our homes, and to start enabling the shift in the industry sector. So the priority for the first 10 years has to be the shift in our electricity system, something where Texas has already made significant progress because of its abundant resources of wind and solar. And the other thing we have to do in this first decade is to finalize the pathways to get to agreement on the pathways for those harder to abate sectors. How are we going to scale up hydrogen? What are the sensible technologies? What is the right technology for shipping? How do we make steel without emitting CO2? What is the technology for clean cement production, etc.? So a goal of 50%, clean electricity, and alignment on the pathways for the harder to abate sectors.
So what does the government need to do? Like what does corporates need to do? Who plays what role? Because that's a lot of money to invest in the infrastructure and potentially replace a lot of infrastructure to enable this transition. What policies do you suggest, and what do you think corporates need to do to act?
It is critically a public-private partnership that is going to deliver this sort of ambitious roadmap. Businesses can't do this on their own. There is tremendous leadership emerging in the business sector around the world. CEOs are stepping up, boards are starting to pay attention to climate change as a systemic risk, but on their own, companies cannot deliver on this net zero pathway. They can govern the risks appropriately, they can make the early investments, they can show leadership, they can lay out commitments, but they also need an accommodating policy framework from governments. Governments, on the other hand, can do several things. The first thing that governments need to do is put a price on the externality of carbon. Every economist around the world, economists on the left-hand side of the political spectrum and on the right-hand side of the political spectrum, have been calling for a price on the externality of carbon, just like we price other externalities. It makes a lot of sense. And with that, we will then mobilize significant capital towards the low carbon solution. But a price on carbon alone will not be enough. We also need some regulatory measures. One very good example that we're all comfortable with is building codes. Building codes set the direction for how we build our commercial buildings and our houses. And if the building codes of the future create a clear mandate for taking gas out of the built environment and making our buildings more efficient, then the technical solutions are there. They don't cost a huge amount of incremental upfront cost, and they will just simply get rolled out. And then finally, in addition to pricing carbon and regulatory solutions, we need to continue to invest in research and development and early deployment of those breakthrough technologies that we still need for the harder to abate sector. So what can a government do to enable the scale up of hydrogen? What can a government do to help the emergent technologies for clean cement or for clean steel? And the natural reaction is often, well, government shouldn't be picking winners. But look at the tremendous success of the loan guarantee program that the Obama administration put in place after the 2008-2009 financial crisis. Many very successful energy solutions and clean technologies, including companies like Tesla, emerged as a result of that loan guarantee program. So more stimulus of the new technologies that we need would be the third leg of a policy agenda.
Perfect. Thanks, Jules. And that's a terrific segue into what Amy Jaffe is prepared to talk about the role that technology can play. So over to you, Amy, if you want to share your perspective, and then we'll bring Jules and Amy back together.
Well, thanks so much for having me. It's a pleasure to be here at the conference. Sorry we're not all here in person. I would be planning out my takeout food agenda for Houston, because I have so many different favorite restaurants. So I'm going to talk a little bit about, as you mentioned, Regina, on digital, following up on Jules. And I'm going to be a little more here and now than Jules and most of my talk, because I think we can already get a little bit of a window on some of the things that are happening and how it's affecting oil and gas in Houston. We can see a little bit of that window today, and we don't have to wait till we get to the net zero deadlines to see what's coming. Next slide. So the influencers of the oil prices have really changed for this year and probably next year. That's because as demand disappeared suddenly because of the lockdowns across the world and in the United States related to the COVID pandemic, we saw this giant build in inventory levels as companies and governments struggled to respond to the unexpected drop away of demand. So we're now in this crazy situation where we have, somewhere between 900 million and 1 billion barrels of excess inventory in storage going into the winter this year. And that's producing all kinds of anomalies. One, of course, is a cap on the oil price. One can imagine that in a normal time, you might think about geopolitical risk or other kinds of risk, or even the immediate cut in CapEx spending for short-term cycle barrels. Might have produced a price increase, but of course it doesn't today because of this giant inventory cover. And you get to this other question, which is I think there's a general consensus in the industry that, the cut in CapEx is going to matter, and it will matter over time more seriously once this inventory is worked off. And that raises this question: we have an economic recovery in 22 or 2023. What would that price increase look like? How fast would it be scotched out by short-term barrels or the kind of stimulation of clean energy that could come from a higher oil price? I think that that's an interesting short-term question because it will really influence the kinds of things Jules is talking about in the longer term and give government flexibility to act. And I think the other part of the debate is in this COVID world, in this post-COVID world, how much more decoupling have we gotten between economic growth and economic activity and oil use? And I'm going to talk a little bit about those things that have maybe be structural and they're not going to go away, and what they mean for oil demand and those things that aren't. So next slide. So we've all kind of seen some of these statistics, but just to review for those of you who don't spend in the weeds on oil and gas every day, the estimates are that on average for the whole year, we're going to have something like global oil demand will be something like 92 million barrels a day. That is instead of about 101 million barrels a day. So significant drop, but not 50% or some giant thing there. There's a thing that people say in the industry to make themselves feel better that, people are afraid to take public transportation and so you're going to get more driving. That is not actually true in the United States. Our US miles driven in September was down about 1 billion miles compared to last September. And it is true in some other emerging markets like India. We're seeing an uptick in gasoline demand this year, but then overall oil demand in India is down 15%. And you might find that if there's another lockdown or outbreak that even this commuting to work that is driving gasoline demand could subside. Chinese oil demand, I think it's a black box. People say it's up, but it's really masked by the fact that the government itself is having a massive stockpiling program. And you hear people saying that Chinese inventory is starting to max out, like they can't even buy anymore because their inventories are so full. So I think it's very hard to know how much is this extra driving and avoidance of public transportation really mean in China, and how much is demand really actually off on an annual basis. And Europe is looking a little like they're getting a little bit closer to normal, and now we're having clouds on oil demand. Now, structurally, jet fuel looks like the weakest part of the complex. You already had some loss in oil growth for demand related to the trade war. That's probably going to continue and accelerate. And so I do think you have some cloudy picture that's just from the change. After September 11, believe it or not, it was actually 4 years before Americans started flying at the pace they had prior to that tragedy. So if you think about the pandemic and the uncertainty, we're probably talking about a longer and larger impact than that event had. Next slide. So the other thing that I kind of try to point out in thinking about gasoline, and I'm not a believer that electric cars are going to just fly into the market, because I lived in California and I had an electric car when I was living there, and I helped the state with their policy. And one of the things I advised the state of California and did some of the research too was to think about clean fuels in freight, last mile deliveries, and long haul trucks. And that is because it's very hard to get consumers to pivot. You have the chicken egg problem. You have the early adopters, which was great in California. And when you get past the early adopters, the pace is, been very successful in Norway, but not so much in California. But the new big thing, which California has now joined, and we have actually modeled it, is how many countries will ban the sales of new IC engine gasoline cars. And you're starting to get momentum on that policy. COVID is accelerating that policy. In some places, the UK had talked about it in a very vague way. All of a sudden, they made an announcement that they're going to do it by 2032. And our research on diesel markets shows that if consumers and car manufacturers start to see a shift coming like that, it affects purchases right away, because consumers don't want to be buying a certain kind of vehicle and then have to worry about, most people in America anyway own a car for over a decade. So you don't want to be owning a vehicle that you can't get maintained well, or that you might, have less distribution system for fuel. And the interesting thing is we have these competing trends. Trend number one is that new car sales are way down in the United States and way down in China and India. And so, even if in China the high percentage of cars being purchased are electric, the fact that you have a slower turnover of the car fleet, really slows down the transition of vehicles. And, doubly so in the United States. So, good year to own stock in Carvana or CarMax, but not a good year to own stock in a car manufacturing company. So, so we have these sort of competing trends. Next slide. But the other thing that is a trend that I do think is going to gain momentum, not only because of climate policy, but because of COVID and because generationally, is that you can see that, again, from our modeling, and this has been more prevalent in Europe, but starting to kind of catch on in the United States, what happens if cities, especially, start to close off streets for single rider cars. In Europe, you have these city centers where cars are actually banned. You have these visions of the future where maybe individual passenger cars with individual drivers will be banned, but there'll be some kind of automated vehicle system that could be electric. Imagine an Uber with a UV instant cleaning system and no driver, moving people around in a place like Manhattan or Houston. Would really change traffic patterns, and that probably eliminate some of the fuel that gets wasted when people are stuck in traffic. So, so you have these sort of competing trends. You have the people moving in the United States. You have people moving out of cities, or some of the bigger cities, and there's debate about some of the research debate about whether that increases gasoline demand or lowers gasoline demand, but the statistics so far are showing it lowering gasoline demand, not increasing it. And then, of course, we have this new phenomenon of the telecommute. We're doing so many different things. Imagine how all of us would have had to driven to come to this conference in Houston, and we all have to, I would have had to leave an extra hour so as not to get stuck in traffic. So, as a speaker, so these kind of lifestyle changes are oil reducing, I think, in the longer term. Next slide. So how do the things I'm talking about, and I'm going to talk about some other technologies in a minute, how do the things I'm talking about square up in terms of the industry's access to capital? Because, that's a big topic today is, will investors, shift the capital away from oil and gas? Will shale companies, E&Ps, be able to actually raise capital in the future? Exxon stock just keeps sinking relative to other kinds of companies. Today's announcement is they're no longer bigger than Chevron in capitalization. Previously, they were no longer bigger than NextEra. Before that, they were no longer as big as Tesla. And I think that one of the interesting things, and maybe BP and Shell are more responsive to this than others, and it might even be a feature in the E&P business in terms of which E&Ps are favored and which ones still have struggled to get capital. And that is, you have a lot of investors looking for companies and wanting to ride the wave of technology. And some of the technologies that are coming in companies that seem like an energy company or an automotive company, there are technologies that are being deployed that have applications that go beyond an energy application. So, you think of Tesla as a car company, you don't understand why the stock is up because, hey, that's ridiculous because, how many electric cars are there really going to be able to sell in China? There's 100 Chinese electric car companies that are competing against them. So it's a pretty competitive landscape. But if I were to tell you that Teslas, which a lot of people don't know, have a filter system that is intended to protect you in a bioterrorism attack, and then you're telling me I'm selling Teslas in China, given the fear of pandemics and the fear of bioterrorism in general, that'd be a pretty popular car if you could afford it in China. That would mean that compared to every other car, superior car. And then of course that technology, that filter technology in today's world, Tesla can upgrade it to be a building technology. And then all of a sudden that's even more valuable. And then if I tell you that they have this battery in their car, and because it's in a car, it's cooled by a liquid chemical coolant. And I don't have to explain this in Houston. And those batteries are being used in Australia to back up wind and in Los Angeles to back up solar, and all around the world they have an energy utility business. And if I explain to you that their batteries are cooled with a liquid coolant that's built into the system, but they're competing against some companies that have batteries that are cooled because there's a diesel generator sitting there as a backup to keep the battery cool, you can understand that Tesla has a superior backup, that's a superior technology, and it's beyond the car. It's the utility business, and it's going to what we call solar virtual batteries. So I have a building, and everybody in the building or community has some solar energy, and everybody in the building has an individual battery, and the utility or the distributed energy organizer has a written agreement from everybody that they can use 30% of the battery at a time for load peaking, right, to cope with load peaking. So a lot of technologies coming out of Tesla that aren't the car. And that's what the market's looking for when it favors these stocks, in addition to the fact that, right now it's trendy to invest ESG in clean energy. But I think that, when you look at a company like Exxon, which has promised progress on CCS, but not delivered it in a commercial venture and scaled up deployment, compared to some of the Amazon, doing what they're doing, and Google delivering a self-driving car with the Waymo tests in Arizona and other places, Exxon is not delivering in technology for the future what it said it was going to, even having deployed a lot of money on it. So the market is responding to that. It's not just about, what's your view of the oil price this week. It's also that, are these Houston companies positioned in technologies that are going to be increasingly valuable, not less valuable? And I think that's a big piece of it. Next slide. So what are some of these technologies that I think COVID might accelerate that would be carbon eliminating? Next slide. 3D printing. So some people say, well, 3D printing uses more electricity and certain kinds of materials, and that could be emitting. But that's true. But if you think about 3D printing from an operational point of view, and I think in Houston, we can understand how COVID immediately accelerated it, because I don't have to explain, but just to commend Baker Hughes from taking all their 3D printers and pivoting them to make medical equipment during the height of the pandemic in Houston. If I'm making things with 3D printing, with using graphene or some other components, then I'm not manufacturing pieces of a different equipment in many different locations and shipping them around the world, and all that shipping in boats and shipping in trucks to the place where I'm assembling the final product is very oil intensive. And if I'm not going to do that, if I'm Cessna, and I used to have an engine that had 965 parts, and now I'm going to 3D print it, which is true with the Denali plane, and it's going to have 8 parts, and I'm going to print them right where I'm making the plane. That's a lot of oil that was eliminated, moving my 465 parts around. So I think the 3D printing is going to wind up being very oil saving. And then, you have these other technologies like battery storage or maybe hydrogen, which are going to compete and make it more competitive for electricity and hydrogen to compete against oil. Next slide. So last word about hydrogen. So again, to think about how it could lower emissions and what it would mean for the energy industry in Houston, I was recently working on, as part of my new job, apparently one of the top engineers in the world on deep water wind is at Tufts. And I met with him and we did a blog, and it was very interesting to hear what his thinking is and the recommendations Tufts has for state of Massachusetts and New Jersey. And the most interesting part about it was looking at the giant scale up that's expected across the entire eastern seaboard down to Virginia in deep off-water wind. And then comparing that to this thesis which is out, which is a Bloomberg New Energy Finance projection on how within the next 10 years, electrolyzing manufacturing equipment will be cheaper than blue hydrogen, which would be natural gas with CCS. And if you think about New England wind and its role, and you think about how much natural gas is needed and used for peaking, the industry has this thing that it says the energy transition can't really happen because we need to have this natural gas because it has to back up wind. Well, suppose the cost for putting an electrolyzer in the next 5 years might not take 10 years. If China is going to manufacture all these components, or Europe's going to have a big initiative manufacturing components, maybe it's going to go faster once you have scale up. And suppose all this wind comes on in New England and it's paired with electrolyzers. That entire market for natural gas, which was already, being competitive against with, Hydro-Quebec was a main, big competitor for Vermont and other states that wanted to go to 100% renewables. You're talking about a completely different program if you're going to be able to use hydrogen as the backup, seasonal backup for this giant amount of offshore wind that's going to come online. So I think with that, I'll end my formal comments and we can go to the Q&A session.
Thanks, Amy. That was really instructive. I'll just do one question with you and then I'll shift to both you and Jules. In your paper, you talk a lot about the unintended consequences of some of these technologies, and I thought that was a really important part of your paper. Could you share with the group what you mean by that and give an example of some of those unintended consequences?
Well, again, these technologies can swing both ways. They can be very energy efficient saving, or they can be very energy generating. So one of the things we know, one of the enabling technologies, of course, was ride sharing. Pre-COVID was ride sharing. Right. But actually what the real data shows is that, and the millennials in the audience won't like my pointing this out, all this millennial ride sharing was not actually carbon saving. It actually dumped people out of public transportation. I think in San Francisco it was like 25% of people who were doing ride hailing said that they would normally have taken public transportation. So it was increasing gasoline use in certain cities. It was raising emissions and congestion. In New York City, it was raising so much congestion that the city started to put limits on it. And in California, you were seeing a momentum, which I think we're going to see, where the Air Resources Board said, listen, it has to be a zero emission car by a certain year. We want a snapshot of the emissions from your entire fleet of ride-sharing vehicles. and we want to know how you're going to reduce the emissions over time. We're going to tax you, or the carbon tax, or whatever's going to apply. So you do see this pivot for some companies. Amazon, Google, some of the companies have said, Uber have said that they're going to go to 100% electric.
Mm-hmm.
In China, I think there's a push to try to push cars to be electric. So there's a tension there, because of course, if everybody's ride sharing and then it goes to automation and everybody's using these robot taxis and they're all gasoline, actually could increase emissions from transport. Same thing with self-driving trucks. Is the truck going to be hydrogen? Is it going to be electric? Last mile going to be drones, which probably would be electric or hydrogen, or is it going to be traditional vehicles? In which case, having everybody, having these last mile deliveries, if it's going to be fossil fuels, unintended consequence. But I didn't talk about this. One of the benefits of e-commerce versus you and I going to the mall, it's not good for jobs, but it's good for emissions, because again, when I was at UC Davis, we did some research on this, and it turns out that when a company like UPS, which has done this, uses big data to decide what packages to put on what truck and what order they get delivered in and what route does the truck go. That's what these large companies do now, Amazon and UPS and so forth do this. It actually saves a huge amount of fuel. UPS switched over to this system in 2017, and they saved 100 million miles of vehicle miles travel in 1 year just putting the computer on. And it's how they can tell you that your package is arriving at 3 and not at 7, right? Because the driver can't make his own decisions anymore about what he does first, second, and third. It's all computerized. But again, if we're in a natural gas vehicle or we're in a gasoline or diesel vehicle, then we're not saving as much as if we're in a clean vehicle.
Mm-hmm, mm-hmm. Great. Well, Jules, let's bring you in. Amy talked a lot about the importance of technology, as well as what might happen to oil demand in a post-pandemic environment. What were your reactions to her presentation? What stuck out for you?
Yeah, there are a lot of areas where Amy's perspective and our perspective is very much aligned. And then there are some areas where we may be a tad more bullish about the speed at which things might be going. For example, in the automotive sector, I think it's completely understandable that people look over their shoulder and say, gosh, it's been complicated, there's range anxiety, there's not enough charging infrastructure, there are not that many models available, it will take a long time for electric vehicles to emerge. But now that countries across the world and a state like California are putting a clear ban in place for new electric vehicles by 2030 or 2035, suddenly the writing is on the wall. And if you're a senior executive at BMW, Volvo, Volkswagen, General Motors, you have to contemplate where are you going to put your platform development efforts. Developing a new manufacturing platform for a car is a $1 billion to $2 billion investment, right? And you need to sell a certain number of cars in order to earn back that investment. You're not going to be able, not even the largest automotive companies, you're not going to be able to maintain those two platforms, internal combustion engine and electric vehicle side by side. You're going to have to pivot. And that's what we've already heard Mary Barra signaling. That's what we've seen Volkswagen and Volvo commit to. I think Daimler is on its way there. We'll see these car companies say, you know what, by 2025, by 2027, the bulk of our new vehicle investment and our new volumes will be electric. And that will then further accelerate the scale up of these technologies. And the second trend that we see is these unrelenting cost declines associated with the learning rates put batteries now on a path to be $50 a kilowatt hour, maybe even less in the next 3-4 years. That means the electric car will be cheaper upfront than an internal combustion engine car. Now, I happen to drive a little Tesla. It's faster. I don't have to pay at the pump. I have lower maintenance. it's a really cool car. But what if all those benefits come with a lower upfront price? Suddenly the choice becomes pretty darn obvious, right? So I would say that the writing on the wall for the internal combustion engine will accelerate the shift of the automotive OEMs, will drive more electric vehicles into the market, and will start squeezing out a significant part of the barrel, in addition to the jet fuel part that Amy already pointed to. Those two means that I think it is totally conceivable that we are living peak oil right now. That peak oil is actually happening as we speak. That oil demand will never go back to the sort of 100 million barrels a day that we were seeing last year. And obviously the impacts for a whole industry, the oil and gas industry, of that sort of a shift will be very significant. And it is why you are starting to see companies like Shell and Total and BP noodle on their future and think about the role they can play as integrated energy companies rather than oil and gas companies.
So let me just weigh in for a second. I hear everything Jules is saying, and I hope what he's saying comes to pass because it's imperative because of climate change. But, and there's a but. So most car companies only change their platform once a decade, and part of the problem now is there's no sales, and you have people, all the car rental companies are putting their vehicles out into the marketplace, and so you have this sort of stickiness. You have one stickiness, which is that people normally hold the car for many, many years. In China, 6 to 7 years, Germany, 6 to 7 years, the United States, 10 to 14 years, right? And that's, in a good economy. And then you have this problem about the cars changing the platform. And I agree with Jules, once the paradigm shifts, as we saw in Norway, it can shift very fast. But, as a person who goes to Oslo frequently, you can walk around Oslo and it's a pretty small city. And there's definitely no range anxiety in Norway. So my point to you is that I had an electric car. And when I moved back to New England, my intention was to get another electric car because the electric car I had high performance wheels, and we kept getting blowouts because more potholes than in Northern California because of the weather. And, really limited number of choices. And unlike Jules, I'm just not in a financial position as a professor to buy a Tesla. So, very limited choices. And even this year, I leased the car briefly because I thought, well, okay, by 21, there'll be so many models of electric cars available. I'll just buy one in 21, and I'm not going to commit to having a car and then selling it after 2 years. So I'll just wait. And again, in 21, not a lot of choices. So I agree with Jules, the numbers are going to come down. It's going to be very competitive. You've got government policy falling in behind, all these things. But it's sticky. It's sticky and it's hard to move it fast. And I think that doesn't mean the industry's out of the woods because the kinds of things that are going to eliminate demand first is, guess what? I've always worked from home. Even when I worked at Rice, I would go in to teach and meet with people, but, I like to sit and write at home. And when I work as a journalist, I work from home because I have little kids. So I've been working from home from a long time, but now the rest of everybody else is working at home with me. And guess what? For people with little kids, I managed it. And if you're a woman in the audience, for sure, email me and I'll give you some pointers. But the answer is a lot of people are working from home. They're not commuting. And you're going to see these different things that if, God forbid, there was some crisis in the Middle East and we suddenly didn't have enough oil supply, which seems hard to believe is going to happen next year because we have 1 billion barrels in oil in inventory. But even if something like that happened at this new stage, there's so many ways I can fix that. I can telecommute, I can ride share, I can do a combination of telecommuting and ride sharing. I mean, there's
Right.
just so many ways of getting around it today that we didn't have in 1973, that I don't think the storyline that people don't want to go on public transportation, or that it's going to take longer to get consumers onto electric cars, I don't think that storyline means that we don't have oil demand at lower levels.
Right.
And that's really sort of my message, which is, trade war, international travel, telecommuting, all these things that COVID accelerated, these technologies were coming anyway, but now they've come much more quickly.
So let's get to some of the questions from the audience, and keeping on the internal combustion engine. There is a question about how does the ban on internal combustion engines work in terms of the hydrogen economy? Because with fuel cells, it seems like it's potentially more of a transitional type of a battery opportunity. So does the total ban, I guess the total ban on ICE, does that threaten the move on for hydrogen?
Well, okay, go ahead, Jules, you can go first.
I don't think that a internal combustion engine ban would cover a hydrogen car, because hydrogen in most electric vehicles would go to a fuel cell and power an electric engine. So I don't think that would apply. I will say, though, that it is our perspective at Rocky Mountain Institute that for most of the automotive industry, hydrogen is no longer a viable option. I know Toyota is still trying. I know Shell is still rolling out hydrogen fueling stations in California. But in our view, the cost of batteries and the unrelenting decline of cost of batteries means that basically that is game over. So that really would only cover heavy duty, long haul trucking. And there, I think hydrogen is not combusted, but is in fact turned into electricity. So an ICE ban would not apply.
Okay. And then there's another question about batteries and the life cycle of batteries and the damage that can do to the environment. So let's address that one, since you brought up the battery question. We'll start with you, Jules. Your face is on screen.
Yeah, so that is a very important question, right? We cannot replace one sustainability problem with another problem. Here's the good news. The developments in battery technology, and particularly in battery chemistry, are very encouraging in the right direction. Tesla has already engineered cobalt out of its next generation of batteries, and we'll see these chemistries becoming simpler, less reliant on scarce raw materials, less reliant on materials that are not sustainable. I wouldn't be surprised if 5, 6, 7 years from now, we'll actually see chemistries emerging on very common materials like aluminum or zinc. So yes, in the short run, it is something that needs to be addressed and that is important to be addressed. But in the longer run, I think the battery chemistries are going to help us a long way to address the sustainability concerns around battery.
Question for you, Amy. It's about the offshore wind and the potential for hydrogen on the East Coast. Somebody was asking, how would they move the hydrogen around given the Eastern Seaboard's reluctance around pipelines?
Well, that's certainly a legitimate question. And there are activist groups that object to hydrogen as much as they object to natural gas. I think the first question is, and maybe this is harder in New England than in California, where I think it's being looked at more proactively, potentially in the Midwest. In Europe, one of the things people are looking at is blending hydrogen into the natural gas system. So if you have already a utility that's hydrogen ready at the burner tip, which at least in Europe they are, but believe it or not, there are cities on the Eastern Seaboard that, pre-World War II had hydrogen, so maybe some of that equipment, ironically, is still there. You can remove the hydrogen stream from the natural gas pipeline, or, some places, if you have high quality pipe, you can just keep the hydrogen in there, and it's sort of 5% or 10% improvement on the environmental quality of the natural gas stream. So that's one. If you're already having a pipeline that's already there, and that, in my view, would argue that the industry makes a huge error in saying it's too expensive to repair their pipelines for leakage, because of course you won't be able to pivot any hydrogen into a system that has any cracks or compressor stations that have massive leakage and so forth. So a pipeline company that is ahead of the curve, that is a good midstream company with good maintenance of its facilities, that's gone to modern materials, whether that's high quality plastics or so forth, is going to have a really big advantage in the evolving hydrogen economy than a company that is saying, well, a certain administration won't require me to do methane leakage, so I'm not going to take care of it. That's point one. And point two is you have a lot of innovation coming. So I've met with people that have new systems for transporting hydrogen. There's a couple startups in the United States that have a canister-based hydrogen system that people think can even be pivoted into airplanes to feed fuel cells in planes. And you have the traditional unhealthy method, which of course is to truck it. So at some point, people have to decide, because now, I meet with people and they say, hey, listen, we shouldn't do wind because there's a lot of emissions in manufacturing the blade. Like, at some point or another, we either going to make this commitment and try to do this, or we're just going to, suffer the consequences of global warming, which is pretty unimaginable if you were there in Hurricane Harvey, or I tell people I've been a climate refugee more than one time. Right. Not only did I have to evacuate all these floods in Houston, I then moved to California, and I can't get home from my office in Oakland back to Davis, California, because there's a wildfire and the highways are closed.
Right? Exactly.
So, I've seen a lot, and it's not pretty. Right. And the health consequences are just unbelievable as well. Right? Mm-hmm. So I think that the idea that citizens of different countries are going to just sit and suffer, and they're not going to want their government to try to do anything to ameliorate things, that just seems really unrealistic to me over time.
So I think we have time for like one final question, and I'll give you both a crack at it. And we'll start with you, Jules. You talk about we've reached peak oil. That's a pretty scary prospect for Houston. So most of us are sitting in Houston. What is your recommendation for how the city competes, the role that we can play, and then the companies that we serve within the oil and gas space? What should we do?
Yeah, that's a very good question. And let me start by saying, Regina, I started my career at Shell, spent 10 years at that amazing company. If you contemplate the disruption to an industry that has brought so much good to the world over the course of the last 20, 30, 40, 50 years, then yes, it is hard to contemplate. And it's hard to contemplate that for a city like Houston, but for places around the world, right? So obviously there's a whole set of questions around a just transition that I don't want to get into right now, but that need to be considered in Houston and in Aberdeen in Scotland and in the Middle East and so on and so forth. But if you are contemplating what it means for Shell, for Exxon, for a smaller oil and gas company, it really forces you to think through whether your long-term strategy revolves around cash cowing the business and may the last one turn on the lights, or shifting the business and moving it to the direction of the future. Mm-hmm. I often tell people an anecdote. When I finished high school, I spent my summer in a job working in the Remington typewriter factory in my hometown. And this clearly dates me. I probably don't need to explain to people what a typewriter is, but if there's some young people in the audience, I may have to. In any case, that factory did not survive. If Remington had decided to move from the typewriter to the digitally enabled workstation to personal computing, they might have had a tremendous success story. They didn't, Remington typewriters doesn't exist anymore. Along the same lines, the oil and gas industry has to bet on the future. And the future of the energy world is one of green electrons, not, and potentially green molecules as a result of green electrons, power to gas, but not a future of molecules. And as long as the oil and gas sector generates significant cash flow out of its existing oil and gas operations, those cash flows can be generated, can be used to create, to build an electron business of the future. That seems to be clearly the path that companies like Shell and BP have embarked on. On the other hand, I see US oil and gas companies saying, no, this is going to take 100 years. We can't do it. We're still inventing the carbon capture and storage solutions or the biofuel solutions of the future. And they're making a real bet. They're making a bet that they will get the time to do this transition over the next 80 to 100 years, which, right, as Amy was pointing out, is not compatible with the issue of climate change. So in my view, deploy the cash flow coming out of oil and gas to rapidly build a green electrons business, potentially a green molecules business from power to gas. Build that business at scale in the areas where you have a competitive advantage, either in a certain region, you're strong in Texas or you're strong in the West, on the West Coast, or in a certain segment, you have a strong niche in petrochemicals and you figure out a way to convert green molecules into green chemicals. And move relatively quickly and boldly in redirecting your capital from the old to the new. That would be my recommendation.
Thanks, Jules. Amy, as a former Houstonian with roots in Houston, what final words would you offer for Houstonians to consider in our final couple minutes?
I just want to remind everybody that with the wonderful help of Isabel Brown, I organized the Texas Philosophical Society meeting in Houston years ago and talked about this rejection of science R&D in Houston, right? And in Texas in general at the time. I won't name names who was the governor at the time, but you can all guess. And think about a couple of things. Number one, you know who one of the biggest, everybody's talking about BP and Shell. You know who one of the biggest purveyors of investment in clean tech these days is? Saudi Aramco. So if you're sitting there in a E&P or in a large cap and you're thinking you get plenty of time, you might want to think about the fact that the Saudis are working on tailpipe emissions capture on trucks. They've already announced they're going to, blue and green hydrogen. That train has left that station in Saudi Arabia with Houston, with a company like Air Products. So you're seeing that, and I'm seeing companies. I was recently doing a project for a company that's a big midstream company, and if you take some of these companies and you make a map of where their infrastructure is, and you look at how close it is to renewable infrastructure or potential renewable infrastructure, there's a lot of contiguousness now. Mm-hmm. And in California, we studied, would it be cost effective if you were putting in a new pipeline to put in steel that was of a hydrogen quality, or to put in stations that could have both electricity and gasoline or whatever. And in the short term, it looks like, that's like a waste of money. But I think what Jules is saying is really true. My opinion is, if you look at how much of the current revenue stream, Amazon and Tesla and others, guys can Google my op-ed in the Chronicle to get the exact statistics. I forget off the top of my head, but it's something like 30 or 40% is reinvested in R&D and new technology. And the oil industry, it's like 2 to 8%. And then when people go to greenlight FDI, Total and BP have made these announcements of how much CapEx they're going to shift to new technology. But, you know, I was sitting around with one of the European majors last year when you could sit around with people in person, and I'll just throw out this last thought for the industry. So you're telling yourself that you get between a 12 and 17% rate of return on your dollar invested in oil and gas. You know that that's not actually true. That's what you're telling the board when you put your project up with PowerPoints. And, you know, I mean, no offense to the Center for Houston's Future, we just had a whole panel, you know, for the controller about, you know, under this oil price scenario and that oil price scenario, what would Texas revenues be for royalties? Well, you know, I can make it sound good or I can make it sound bad, depending on what I use for my future oil price. I can make it anything. We all learned that from Enron. You know, they did these derivatives, 20-year derivatives, and they just made numbers up to make them look like they were in the money, right? So we can all do that, but that doesn't mean it's real. So if you go backcast and see what your actual IRR was in, you know, Gorgon or in, you know, LNG here and there or in far scale Arctic or wherever, you know, it's not 17%. And I can tell you for some of the people who invested with PE and shale, it was like -3% or -10%. But people who invested in project finance for renewables are getting between 7 and 10% guaranteed revenue. And when the European majors invest in those projects, they confirm to me they're getting that 7 to 10%. And I asked them, when was the last time you got 7 to 10% on one of your large scale oil and gas? And they had to admit, not recently. So, right. You know, this mythology that we can't pivot because we lose money in renewables and we're just making a fortune in oil and gas, like that's really not accurate. I think every company ought to sit down and actually have a quiet meeting before they have their committee, upstream committee. They need to have a quiet meeting with, if they have downstream, with the downstream group, and really look critically, because there is this disconnect between the kinds of monies that people who are putting their money into some of these renewable projects are getting and the actual returns in actual oil and gas.
Right. Very sobering. Thanks, Amy. Big round of applause for Amy and Jules. I wish I was there to really applaud you. Appreciate your time on the panel. And over to you, Brett, to close us out.
Yes, what an amazing discussion. Regina, thanks for doing that. And thanks for Amy and Jules for being with us. You know, what I heard was we need to pivot and it needs to be quick and bold. So those are the things that I'm taking away from the discussion today. Really what we need to figure out in Houston is, you know, how do we do that? Because Jules mentioned in passing this idea of just transition. I don't think we want to go there in Houston. I don't think we want to be on that side of having to think about the world that way. We want to be the leader in this area, and there's obviously a lot of work to be done to do that. So that's our discussion next Thursday. We're going to do the same thing over again to really think about what does this energy innovation ecosystem look like at some detail. And so if you haven't signed up for that conference, please do. I think it'll be a really interesting discussion. And we're going to close it out with another amazing keynote at the end from Franklin Chang Diaz, who is just an amazing individual, more shuttle missions as a NASA astronaut, and plus building a really cool rocket ship, rocket engine to Mars, and in his spare time, building a hydrogen infrastructure in Costa Rica out of parts that he buys off the internet. So you'll want to hear that. It's amazing, and it'll be a really great show. So please do that. And remember that we're having at University of Houston the symposium over the next 4 Fridays on each of the areas that we've been discussing. So hopefully you'll sign up for those as well. Again, thank you for all the speakers, and really thank you to this last panel for really an amazing discussion. I appreciate all the great thoughts that you've given us. And we'll close it out for today. So take care until next week. Bye, Jules and Amy and Regina. Thanks for all your time and effort on this. Bye now.